For the positive integers 1 to n, we're going to space them around a circle in such a way that the sum of any two neighboring numbers is equal to the sum of the two numbers diametrically opposite. So in this example with n equals 6, 1 is diametrically opposite 4, and 2 is diametrically opposite a. And it must therefore be that the sum, the two neighbours, 2 plus 4, is equal to the sum of their diametric opposites, 1 plus a. Therefore, for this to work, a has to equal 5, so they're both equal to 6. And we're asked to finish off this diagram, so we've also got 3 and 6 to put in. So if we maybe pick 2, so these two, so let's call this b. So it must be that 2 plus b is then equal to c plus 5. And if I let b equal 6 and c equal 3, then I'll get 8, and it all seems to check out. 3, 6, and we can check some other ones. So 3 and 4 sum to 1 plus 6, that also works. So this is a completed grid. From now on in the question, we've got that n is 222. We're asked in part B to show that the difference between any pair of diametrically opposite numbers is the same. So let's look at figure 6. It must be that x plus y is equal to a plus b in this example. And they're just showing a few of the numbers there. So what that means is x minus a is equal to b minus y. And these are the differences. So this is the difference between x and a. And this one here is the difference between b and y. I've assumed that b is greater than y and x is greater than a. So x is the larger of b and y. Maybe I could write that down. X is going to be bigger than y, and therefore b is going to be bigger than a. I don't think that is essential in this question. It's just, this question's really just guiding us along. So the only thing we should write down, I've run out of space, but I'm going to say it verbally, is we should just say this would actually apply to any four numbers. It's not just these, like this is a general case. So any four numbers in a similar configuration, so the difference between pairs is always going to be the same. We move on to C. Suppose that there's an arrangement in which 41 is opposite 1. So I could write them in a little pair like this. By considering which numbers would need to be placed opposite 40, 120, and 200, show that such an arrangement is not possible. So we would achieve a difference of 40 from these two numbers, and from part B, we've just shown that the difference always has to be the same. So the difference is 40 for all diametric opposites. Now let's consider 40 then, the number 40 itself. It can't be opposite 0. Remember, we're going from 1 to 222 now. So 40 is going to have to be opposite 80, and 80 opposite 40. We jump to 120, then that can't be opposite 80 because I've already got it opposite 40. It's going to have to be opposite 160. And then that leaves us with 200, which can't be opposite 160, but it also can't be opposite 240. You could try and do it, but 240 is outside the range. So 200 cannot be paired. And therefore this configuration is not possible, or this arrangement. Right, on to the main event. Find all possible numbers which could be placed opposite 1. Remember, n is equal to 222. You need to explain why those are the only possibilities. In each case, you also need to explain why it is possible to arrange the remaining numbers. So what I did in this question is just investigate some other possibilities. What if I had 1 opposite 42? You just got to start out somewhere, and I think using some numerical more examples is a good way to go. We've seen that 41 cannot be opposite 1 to get a feel for which ones might be able to. So 41 would then be opposite 82. Just keep adding 41 basically. Then it'd be 123 would have to be opposite 164. And then we'd be left with 205, which cannot be paired. I then decided to jump to what about 51? Because that's just a little bit easier to deal with when I've got a difference of 50. So then 50 would be opposite 100. 150 would be opposite 200. And I wouldn't get this kind of, unpaired one that I had before. However, if you sort of go on to investigate this, we see that 2 would be opposite 52 and 3 would be opposite 53, all the way up to 49, which would be opposite 99. And that kind of actually sorts out all the numbers from 1 to 100. And you get a similar thing going on here. So we'd still be left with 201 with nothing to pair with because it can't pair with 151 because 151 would actually pair with 101 because 101 can't pair with 51 because 51's already been used. What I'm trying to show you here is like some numerical answers of other ones that don't work and why. So at this point I thought, okay, let's go with some lower numbers, see if we can just find anything that works. Presumably there's going to be something. So what about a difference of 1? Okay, so then 1 could pair with 2. Remember, 2 is not going to pair with 3 because we've already used 2. 3 would pair with 4. 5 would pair with 6, and so on, all the way up. And it's always an odd number on the left and then an even number on the right. So we're going to be able to get 221 pairing with 222. This one will work. So this is possible. 1 can be opposite 2. What about 1 and 3 then? That seems the next example to go with. So a difference of 2. Okay, so then 2 would pair with 4. We've almost created a little cycle here, and actually this is going to be underpinning to our solution. At some point, you need to recognize that. 5 would pair with 7, and 6 would pair with 8. So again, we're sort of getting this multiples of 4. And it would carry on like this. So we'd end up with 200, and so this number here is always a multiple of 4. So if I carry it on, then I'm going to get 220 here, pairing with 218, and then 217 pairing with 219, because that will create another little set of 4. But this shows that actually it's not going to work because 221 can't pair with anything and nor can 222. So actually this is not possible. But it's starting to show why something is possible and why something is not possible. So at this point, I had sort of these ideas. I said to myself, right, I can see why 1 and 2 works because I'm creating this, just these pairs going up every time. There's no problem with that. I can see why, like, the difference of 2 kind of nearly worked, but we just ran out of pairs at the end. What about if I have a difference of 3? Just before I kind of try and generalize it, let's investigate that. So 1 would go with 4, 2 with 5, and then 3 with 6. And I've actually used the numbers from 1 to 6. I've created this little cluster, and I'm going up by 6 every time. So my next one would then be 7 and 10, 8 and 11, and 9 and 12, this other cluster. So for this to work, I need 222 to divide by 6, which it does. So it kind of makes sense that if we carry it on, then my last one, 222, would go with 219. And then it'd be 221 going with 218. And 217 going with 220. So as long as we've got multiples of 6 here, this cannot fail. This one here is also possible. So time to generalize. We've done 1, 2, 1, 3, 1, 4. What about 1 pairing with x plus 1? I want to make my life easy and say the difference. I don't want it to be x minus 1. I'm not going to go with x here. I want a difference of x. So then I see that 2 will go with x plus 2. 3 with x plus 3. All the way up to x, which will go with 2x, which is what we're seeing in the other examples. See, this is x equals, well, x is equal to 2 here. Is that right? Sorry, x is equal to 3. So we've got 4 here, and we end up with, see, x and 2x like that. So we create this sort of chain. Create chain from 1 to 2x, and this will then repeat. So we saw with 1 and 3, it didn't work because we didn't finish the chain on 222. For 1 opposite 4, it did work because we did finish the chain on 222. So we require 2x to divide into 222 to finish the last chain on 222. So I can do 222 divided by 2x, which becomes 111 over x. And I require, so x must be a factor of 111. Okay, 111, the digit sum is 3, so 3 goes into 111. 37 times. So 111 equals 3 times, and 37 is a prime number. So actually, 111 is 1 times 3 times 37. X equals 1. Don't forget 1 is a factor of 111. 3, 37, or don't forget 111 itself. And this means 1 can be opposite, remember x plus 1, so 1 can be opposite 2, 4, 38, or 112. It cannot be opposite any other number. As we won't get a whole number of chains. So the only thing left to do is to show that we can actually construct such an arrangement. Before we do that, I think it's a good idea just to check. I've checked 2 and 4. I saw that they worked because I had a difference of 1 and a difference of 3. But what about a difference of 37? And I haven't actually, this is not proven that they can be arranged in a circle. It's just showing that you can pair them up according to the rules. So 1 and 38, and then we've got a difference of 37, so it'd be 37 and 74. 111, that's quite good to get because that's half of 222. That would pair with 148. And then 185 would pair with 222. So you can see that all the pairings are there, and you get the ones in between. So 2 and 39 and so on, basically. Yeah, so hopefully that is convincing. Let's just try and put this into an arrangement. So I've got my circle, and let's say I put 1 here, diametrically opposite 38. And I could then place 2 and 39 in. So I'm going to need to place 2 the other side. And this is what they mean by just showing that it will definitely work. So you just have to justify the arrangement. So that would then work. Okay, these two add to 40. Remember, they don't all have to add to the same sum, but you can see because we've got this difference of 37 for both, then it's going to work. What if we put 3 and 40 in? So if we put it to the right of 39, then we're going to have to put the smaller number in. And then 40 would go here. Because then both of those add to 42. We've still got this difference. If we put it the other side, we've had to swap it the other way around. So for example, if I put 4 and 41 in, then 41 is going to have to go here. So you can see we just keep constructing this kind of setup all the way around. Here's how you can put it into words. Sorry, I'm going to use the solutions now because it is just going to explain it more concisely than I would have. So it says we need to show that each of the situations described above is possible, those numbers that I said. Or you can construct an example. I've already started it off. So pair up the numbers according to the blocks described. And so in our case, it was like 1 and 37, for example, and we saw how the blocks were formed. In fact, I started it off. So put 1 opposite 38 and then 2 next to 38, but we'll put the 2 next to the, yeah, sorry, 2 next to 38 and 39 next to 1, as I showed in the example. So just that, you just don't need to basically justify it. And then the solutions give quite a nice way of then constructing it. So start with 1 and, or in our case, it was x plus 1. Then pick another pair moving anti-clockwise. You could instead go clockwise. Place the larger number next to 1 and the smaller number next to d plus 1. Place another pair and just basically like reverse it. So place the larger number now next to the smaller number and so on. Continue this until everything's been used up. There's 111 pairs. So with the final pair, the smaller number is going to be next to d plus 1 and the larger number next to 1, which is correct. And for all 4 possible values of d, an arrangement formed following this method works. So I wouldn't have written something quite as neat as that, but hopefully you agree that I was getting there with the way I was explaining it. So yeah, that is quite an involved question, quite abstract, like dealing with these things, but A, B, and C obviously help us out a lot. It'd be quite hard if we just went straight into D, but that's what this challenge is about. It's given us a few like stepping stones along the way. It's still difficult even with the help, but you just got to like play around with it. I think that's my main advice. If you're like, I had no idea where to start with D, just try some other examples, get a feel for it. That's what I did. And then I managed to make it work for some smaller numbers. You could sort of see why for these smaller numbers it was working. Then I generalized, got these chains. That's the crucial idea. And obviously this leads on to this main idea, which gives the 4 solutions. And then it's just a case of trying to justify it at the end. Well done on this challenge. Keep going.